Okay, so here's part B. So your idea to subtract here is a good one. And we're going to try to see how we can use our knowledge of algebra to help us avoid a lot of tricky computations. Notice I haven't multiplied anything out yet, not even 13 squared and 15 squared, and certainly not 14 minus x squared. So what happens when I subtract these two equations? What do I get?
Well, you get x squared. You get 14 minus x squared minus x squared.
All right, 14 minus x squared minus x squared
Equals 15 squared minus 13 squared.
Okay. Now, how would you solve this?
Well, I would multiply this part out.
Okay.
It would be x squared. Well, when you multiply it out, it's going to be a huge number.
Okay, yeah, you can definitely multiply this out, and you can multiply those out. Do you see any other way to evaluate these without multiplying them out?
Well, we could use a difference of squares.
A difference of squares tells us, I won't use x's and y's, but how about m squared minus n squared? What does that equal?
Well, it's m minus n times m plus n.
Okay. Here m is 14 minus x, and then n is x, right? So we got to do this minus x, which becomes what?
Which is 14 minus x. It's going to be 14. Wait, 14 minus 2x.
14 minus 2x, because it's 14 minus x minus x. Now we do 14 minus x plus x, which is?
Which is 14.
14. So this factors into 14 minus 2x times 14, which is really cool. How about this side?
Well, 15 minus 13 is 2, times 15 plus 13 is 28.
Okay. What nice little minor miracle happened?
Well, we got this 2. We can divide everything by 2.
We can divide everything by 2. Okay.
And we have this 14.
All right.
We can divide everything by 28.
We can divide everything by 28. Is this side divisible by 28?
Well, yeah. We have the 14 here, and we have the 2 in here.
What happens when I divide this by 2?
You get 7 minus x.
Okay, so I get 7 minus x. The 14 goes away. Equals what on this side?
Is 2.
2. So x equals?
X is, well, 5.
5. Okay, so now it's very tempting, even here it's tempting to multiply these things out. But if you can just hold off on the temptation to multiply out, you end up, in this case, you end up with a difference of squares.
And by miracle it factors also.
Right, and everything just cancels out very nicely. That's not always going to happen. But sometimes it's a little easier. So in this case we've got x equals 5.
X equals
Despite me writing
5.
x equals x equals 5.
So 14 minus 5 would be 9.
9. Okay, and now we got to just solve 5 squared plus h squared is 13 squared.
It's going to be 12.
It's going to be 12.
5, 12, 13 like I thought.
Okay, 5, 12, 13. So what is the area of our original triangle?
So it's 7 squared because we had the 14 squared times 12 squared over 2. I mean 14 times 12 over 2.
Okay, so we get 14 times 12 over 2.
And so we get 7 times 12, which is 84.
84. Okay. So the amazing thing about this triangle is this triangle breaks into 2 integer right triangles. You knew about the 5, 12, 13, and that's where you were headed before, but I wanted to stick to the algebra. But if you said, hey, wait, if this is a 5, 12, 13, then I had a 12, 15 triangle, and it turns out that there's a 9, 12, 15 triangle. Where does that come from?
That's a 3, 4, 5 times 3.
That's a 3, 4, 5 triangle times 3. So that's what's so cool about the 13, 14, 15 triangle is...
It breaks into 2 nice triangles.
And I'm going to show you an open problem, an unsolved problem in math that relates to this.
All
Okay?
right.